Hi viewers, this is Sri Ramulu. So before watching this video, please subscribe it. Don't forget subscribing. Today's topic is a full wave rectifier. In full wave rectifier, both half cycles of input are utilized with help of the two diodes working alternately. So in the full wave rectifier, both half cycles means positive half cycle and negative half cycles, both cycles are utilized. The circuit is seen to comprise of two half wave circuits. See here, it is a one half wave circuit rectifier and it is another half wave rectifier. Generally half wave rectifier consists of only one diode only, so that is why it is a upper part is a one half wave and lower is another half wave rectifier, so it becomes a full wave rectifier. Full wave rectifier have two diodes D1 and D2, and there is a connection between D1 and D2, that is G. It changes alternate polarity of wave. So main use of G here in the diagram, it change alternate polarity. How does it change alternate polarity? See here. So this is the circuit diagram and generally we call it as a transformer, right? And this is the primary coils and these are the secondary coils. In generally primary coils are always greater than the secondary coils, and here 2 points are allotted given as M and N, and at the center it is G. It is called center tapped, we call sometimes center tapped it is, and main use of this G is to make M and N alternate positive and negative. So alternate positive and negative means, suppose there is a one wave like this. Suppose during this half cycle, positive half cycle, M become positive and N become negative, so it can change like this. During the negative half cycle, this N become positive and M become negative. So like this it change alternate polarities. Okay, so which change? G changes. Next, working. How does it work? When input AC supply is switched on, the ends M and N of the transformer, secondary coils become positive and negative alternately. Here M and N points are given in this diagram just now what I told you. Okay, so during the when switched on, when the AC supply is switched on, when it is on, then end M and N of the transformer, secondary coils become positive and negative alternately. So here these are the points. Right, here it is M point and it is N point of transformer, and these are the secondary coils. Okay, so when it is switched on, then it is positive, it is negative, that is. And next, during positive half cycle, AC input terminal M is positive and G is at a zero potential, N is at negative potential. See here, during positive half cycle, M is positive, N is negative. Okay, so during half cycle, sorry for the disturbance, during the positive half cycle, M is positive, N is negative. Okay, so to the M diode is connected and to the N also diode is connected, and see G always it maintains zero potential. G maintains always zero potential. And now diode D1 is forward biased, that is it conducts and causes the current I1 in the load resistor RL. See, during when M is positive, then diode D1 conducts. N is negative and the diode D2. So N is connected across the D2. Diode D2 remains non-conducting, being reverse biased. So here diode D2 is reverse biased. See the diagram once again. So during the positive half cycle, it becomes positive, it becomes negative, and it is a diode, right? this side positive p type present, this side n type present. Here also p type this side, n type this side. And here which terminal is there, it become positive. So positive positive, it become forward biased. So that is a diode D1. And see the diode D2, it is negative, connected to the negative, and it is a p type. Negative positive become reverse biased. So that is why diode D2 is reverse biased, diode D1 is forward biased during positive half cycle only. Then at RL current will present, means or current or voltage will present. Next, during the negative half cycle, terminal N is positive, G is at a zero potential, and M is at negative potential. Here see, during the negative half cycle, now N become positive, M become negative, reverse. So its polarity changed, that is because of G only. During this half cycle, means during this negative half cycle, diode D2 conducts and current I2 flows in the circuit through the load resistance RL. Okay, so during here what, once again see here the diagram. During negative half cycle, during the negative half cycle, N become positive, M become negative. It is negative, and this side is p type, this side is n type. It is p type, n type. So positive positive forward biased, negative positive reverse biased. So at this case, in this case, it do not conduct, it conduct and allow the current, and that current appears across RL. Next, diode D1 is a non-conducting, thus the current flows through RL in the same direction in the both half cycle of the AC input waveform is shown in diagram. So waveform is also shown, and main use of a waveform is, see what it explained to us. So it is input waveform, whether it is voltage or current, as you wish. If it is voltage, then its output, it is input. Its output is what, voltage output is it is output, final, it is finally a final output, right? So during the positive half cycle, which diode works? D1 diode works. It is for D1, it is for D2. During the negative half cycle, diode D2 works. During the positive half cycle, diode D1 works. During the negative half cycle, diode D2 works. During the positive one, diode D1. Okay, like this. It is diode D1, it is diode D2. And if combine them, you can get like this, right? So this is this one, and it is for here. This is this, and this is this. Okay, this is finally is combination, total, the total output. Next, analysis, mean calculation. Let the input voltage Vi is equals to Vm sin omega t. Vm is the maximum voltage, Vi is the input voltage sin omega t. The current I1 is flowing through the diode D1, and the load resistance RL is given by. Here, during the positive half cycle only, diode D1 conducts, and diode D2 do not conducts. Okay, so it is a diode for diode D1, it is for diode D2 during the positive half cycle only. So for diode D1, the current is I1, just now I explained above. Okay, and during positive half cycle means generally if it is a cycle, full cycle, it is positive one, it is negative one. Here to here angle is pi, and here to here angle is pi to 2 pi. So total here to here final is 0 to 2 pi. Okay, so that is why 0 to pi it conducts, mean positive half cycle it meaning. It is negative half cycle diode D2, it is for diode D2, it is for diode D1. Next, where Im is the maximum current, it is written as a maximum voltage by RL plus RF, where RL is what, load resistance, RF is forward diode resistance. Similarly, current I2 flowing through the diode D2, and load and load resistance RL is given by. So during the negative half cycle, what happens? Diode D1 do not conduct, but diode D2 conducts. So it is a past negative, for negative half cycle only diode D2 conducts. So it is for negative half cycle. Okay, so when it conducts, then its value is I2 is equals to Im sin omega t. Like this, two currents here we are getting. So I1 current is where from 0 to pi, and I2 current is pi 2 to pi. Don't forget this value. So this is important things you must keep in mind. It is I1 is in between 0 to pi, I2 is in between pi 2 to pi. Next, the total current flowing through RL is the sum of the two currents I1 and I2, and it is written as I is equals to I1 plus I2, right? Next to calculation, see DC output power you have to calculate, and it is also called as average current. DC output current or average current, and the average current IDC is given by. So how we write? If in mathematics, in basic mathematics, suppose there are the two quantities x and y, then if you have to take their average, how do? You sum them above, and you may write a number in denominator. So in numerator value present, in denominator also present, but in integral form it is we write like this, above and below. Okay, so above is how we have written, see here, 0 to 2 pi. So for full cycle only 0 to 2 pi. So I d omega t. So here we are differentiating not the simplicity, and it is not with omega, it is combination with omega t only. 0 to 2 pi I d omega t by 0 to 2 pi d omega t. So it is called average. Okay, now, so first, just now I told you, during the 0 to pi I1 current present, and pi 2 to pi I2 current present. So it is I1 current 0 to pi, and pi 2 to pi I2 current, but this negative is taken. It is for positive half cycle, it is negative half cycle. So that is why the value is negative is written. And in the denominator, integration 0 to 2 pi d omega t value is simply this one. Why? Because how we write 0 to 2 pi d omega t means nothing, means we understand here 1. So its integration is omega t, and where to where? From 0 to 2 pi. If you substitute this value in limits value, 2 pi minus 0 becomes 2 pi only. So that is why, so we get here answer 2 pi, right? I think clear it is. Now substitute the values, I value in the above equation. Where in here, see, I1 values and I2 values we have to substitute. I1 values, it is I1 value, it is I2 value, I1 and I2 values. I1, I2 values are both always same. So but here Im is there, and Im take outside common, and it is also, so these two things written outside, and it is like this. Now simply what we have to do here, integration, sin omega t integration, sin integration is minus cos, where to where? From 0 to pi, here pi to pi, okay, minus, and take outside minus. Which minus? This minus take outside, only this minus, here minus and here minus, we are not taking this minus, so it is as it is written. So this minus is taken outside, and apply the limit values. First to apply the pi, and next to 0, here apply the 2 pi, next to pi. So applied, its value is minus 1, its value is 1 only, and here minus, it becomes minus 1, minus half. Cos 2 pi is a plus 1, cos pi is also plus 1. So plus 1 plus 1, it is a 2, it is also minus 2, it is minus 2 become minus 4. It is minus 4, minus cancel, 2 1s are 2 2s are. So finally we get this is IDC is what? 2 Im by pi. Okay, 2 Im by pi. So don't forget this value. Again we use again and again we use in next. So IDC is 2 Im by pi, don't forget it. Next, VDC we have to calculate. So current we calculated, now voltage we have to calculate. And voltage here, DC output voltage. The DC output voltage is given by VDC is equals to IDC into RL. It is according to Ohm's law only. Ohm's law is what? Voltage is equals to current into resistance. Which resistance is taken? RL is taken. Why? Because DC power, DC current, DC voltage present at output only. Input we are giving here AC, and we are getting DC. So that is the main use of rectifier. Rectifier convert AC into DC. So AC we give input, and DC we take output. So that is why at output DC present. So VDC is equals to IDC into RL. IDC value just now I told you. Again we must keep in mind 2 Im by pi. Okay, and Im value is what? It is Im value. Substitute here in this equation. Im value is Vm by Rf plus RL. Now take outside a common RL. if you take the common RL cancel, then what you get? You get this one. And if you apply this condition, generally RF values, the forward resistance is very small comparing to RF, then the ratio is becomes 0. Okay, so what? RF by RL is always equal to 0. So again we use this formula again and again, so this is also keep in mind. So this term is 0, so then what happens? You can get this one. So VDC is what? 2 Em by pi. Next, RMS value. RMS means AC voltage, AC current and AC voltage. It indicates AC and AC current and AC voltage. RMS current means AC current. The value of RMS is current is given by RMS means root mean square. Root mean square, that is the meaning of RMS. First to what you have take root, so it is taken outside root. 1 by 2 is written. Mean, so above what you have done, the mean is taken. So integration by again integration. Just now above I explained you in the VDC, IDC. And a square it is also. Square is taken. Current square. So root mean square. So root value is taken. Mean value means integration by integration. And square value is here. Here square, I1 square and I2 square. Square value is also taken. That is RMS meaning. And I1, I2 value substitute here. I1 here, I2 value substituted. Among them, Im is take outside, but it is square, then it come outside Im square as Im square, and a 2 pi also. So I told you its value, how we get this value. Above I explained you. Okay, now sine here sine square and sine square, but limits are different. Here limit is different than the here limit. But sine square can be written as 1 minus cos 2 omega t by 2. Okay, so there is a general formula, basic formula, just everyone know, the mathematics students. 1 minus cos 2 theta is equals to 2 sin square theta, but there is no 2, that is why it is written this side. Okay, here there is no 2, only sin square is there. Okay, when here theta, then you have to write here 2, so here 2 is written. Okay, right, so this formula is applied. Now take outside 2 common. Yes, taken, here written, and it is this one. Now apply integration inside, just integration. See, integration is applied. So it is integration here written, here and here, individual integration is applied. Now integration formula. So nothing, it is one. Just now I told you one integration with respect to omega t is omega t only. And cos 2 omega t, cos integration is what? Sine. But here 2 you have, by 2 we have to write. Here also same thing, and here also same formula. This formula we gets. And now first apply now limit. Apply the pi value in the place of omega t minus 0. And here in the place of omega t apply the pi. And in the place of omega t, if you substitute 0, it becomes 0 only. And same thing here also. First to 2 pi, next to pi. Here also 2 pi first and next to pi. Already 2 we have, and again this 2 pi. So 2 into 2 pi. Okay. Now, so it is written as this, and sine 2 pi value is 0. Right? 0 by something is 0. Sine 0 is 0. 0 by something is also 0. 2 pi minus pi becomes pi. And this term is also same thing. It is 0. Why? Sine 2 pi is always 0. And now IRMS is equals to, so we don't forget this writing above. It is pi plus pi, and here also plus pi, remaining all are zeros. So plus pi becomes 2 pi. So here pi cancel, 2 1s are 2 2s are. So then we get Im square by 2 whole power 1 by 2. And finally we write it is Im by root 2. So IRMS value is Im by root 2. IDC value is what? 2 Im by pi. Okay, IRMS is Im by root 2 and IDC value is 2 Im by pi. Next, VRMS. The VRMS means RMS voltage can be written as like this according to Ohm's law. VRMS is equals to IRMS into RL. Next, IRMS value just now we got Im by 2 pi, Im by root 2 above, just now. See here, this is okay. Right, and in the place of Im, what we have to do? We have to substitute this value in the place of Im. Then we got this. Now take outside common, RL you have to take. RL get cancelled. Okay. Now RF by RL, RF by RL is becomes 0 according to this condition. When it is 0, Vm by root 2. Okay, this is we got finally. Next, efficiency. Efficiency is what? Rectifier efficiency is the ratio of DC output power to AC input power. It is called efficiency, and it is denoted by neta. It is denoted by neta. Neta is equals to P DC by PAC, DC power by AC power. We have to calculate individual PDC and PAC. First, PDC. PDC is equals to power. Power can be written as a current square into resistance. So current square into resistance. And which current it is? IDC. So IDC value is how much? Just now we got 2 Im by pi. 2 Im by pi. Okay. Next. So apply the square to all. It becomes 4 Im square by pi square into RL. So it is PDC over. Next, PAC. AC power can, it is AC also. Power is equals to current square into resistance. So for AC here also AC. AC means RMS, RMS here. And here RF plus RL, two resistance is taken. Why? Because AC not only present at input and also present at output. Okay, so we do not get complete DC. So certain AC also present. So that is why RL and RF both are taken. Next, IRMS square is IRMS value we know, that is Im by root 2. Substitute here and apply the square value, then it becomes Im square by 2 into RL plus RL. Now substitute PAC and PDC in this equation, then we get this one. Okay, right. And here RL is taken outside common. So RL get cancelled here. Why? Because here already RL is there. And now Im square is also cancelled. This 2 goes upside. Already 2 4 is there. Into 2 it becomes 8. Am I right? So if you do the calculation, you can by pi square as it is, by pi square. And here 8 by pi square term is what you know, 0.812 its value. So it is written here, right? And in terms of percentage, we write it is simply like this. In terms of percentage, 81.2% pi 1 plus RF by RL. It is efficiency. And next is what? Ripple factor. What is the ripple factor? What it explained to us? A ripple factor, the ratio of a ripple voltage to DC voltage, and it is denoted by gamma. What is ratio of ripple voltage? Means AC voltage or RMS voltage. RMS voltage to DC voltage is called ripple factor, and it is denoted by gamma. See, ripple voltage or RMS component means voltage by DC voltage. Their ratio is gamma. And by simplifying the, finally we get this one. So there is a simplification, no need. Just this is IRMS by IDC whole square minus 1 under root. And IRMS value we know. IRMS is what? Im by root 2. And IDC value is what? 2 Im by pi. So both values are substituted here. Okay. Now after substitution, Im and this Im gets cancelled. Okay, this pi goes upside. This pi goes upside. So that is by pi by 2 root 2 whole square. Apply the whole square, pi square, 2 root 2 whole square becomes 8 only. 2 root 2 whole square, its value is 8. Why? Because if you apply the individual square, 2 square, first square it is cancelled into 2. So it will become 4 into 2, 4 into 2, it is 8. And after simplification, what you get? You get gamma is equals to 0.48. In half rectifiers, gamma value we got as 1.21, but here we got gamma value 0.48. It meaning is what you know, in half wave rectifier, more AC present at output, but in full wave rectifier, comparing to half wave rectifier, here less resistance, less AC present. Okay, less AC present. So that is the meaning of this. It explained to us, gamma value explaining how much AC is reduced at output. Okay, how much AC is how much DC converted, how much DC value we got, that is a value that will explain by the gamma only. Okay friends, thank you. Don't forget this video watching till the end. Okay, and before watching this video, subscribe it. Thank you.